Hey guys, this video is going to wrap up this part of the unit. So this is all we need to do in Chapter 3. We're going to move on next to Chapter 4, but they're both pretty short chapters, so I combined them together. All right, we're still going to look at derivatives and how they apply to economics. So in economics, we often look at, like if you were a business owner, how much does it cost to produce the items that you're making? And included in cost of production might be materials for whatever item you're making, the lease on the building, the utilities on the building, to keep the lights on and to keep it air conditioned, all the wages that you pay your employees and your insurance and all that stuff. So that's the cost of production. Revenue is all the cash that's brought in when people buy your stuff. So we are going to compare those two things. We're going to look at cost and revenue. And something we're not going to really look at today, but I do want to mention, is profit. That's what, if you're a business owner, that's what you're interested in. So cost isn't as important by itself. Revenue isn't as important by itself. It's only when you compare revenue and cost, that's what's important, that's what's profit. So again, remember, revenue is all the money taken in. Cost is, okay, now I got to pay this, now I got to pay this, now I got to pay this, what's left over? That's profit. All right, so now if you know that your cost is whatever amount of money, but you know that that's your cost for making 20 units, 20 items, you can get your per item cost by dividing by 20, okay? So we're going to be looking at cost as a function. This is if I'm making 20 items, I can figure out the cost for all 20 items by plugging 20 into my function. Or if I'm making 50 items, I can plug 50 into my cost equation to see what's the overall cost for 50, and so on. But your cost changes depending on how many items you're going to make. And so from 0 to 10, the cost might increase greatly, but then from 10 to 20, the cost isn't increasing quite as fast because you've already started making them, you started buying the materials and all that. So the rate of change of cost is going to be changing. So we got cost, we've got revenue. Hopefully you know what those are. And then, of course, revenue minus cost is profit, in case you need that later on. Marginal cost is the derivative of cost. It's the derivative of your cost function. It's how the cost is changing at whatever item we want to look at. How the cost was changing. How quickly was my cost increasing? Or how quickly was my cost decreasing? Marginal revenue is the same. It's going to be the derivative of revenue, and it's how the revenue is changing at whatever number of items we want to look at. What we would like to see happen is we would like our cost of production, its rate of change, we would like it to be negative. And we would like our marginal revenue, our change in revenue, to be positive. We want the cost to be going down, we want the revenue to be going up. Okay, so I've mentioned that. I'm going to get back to this in a minute, the cost of producing the x plus 1th unit, and it's the rate of change of cost. It's the rate of change. It's the derivative. Okay? Marginal cost is the derivative of cost. Marginal revenue is the derivative of revenue. So the example on here on the front is super easy. It's like, hey, here's the cost function. So do you want to know how much it costs to produce 75 items? Sub in 75 to the cost. Do you know how much money we're going to bring in if we sell 75 items? Sub in 75 and see how much money we're going to bring in. And then, of course, you can subtract them to see your profit. But I want to know, maybe at the 75th or whatever, how fast was each one of them changing? So here I go. I'm going to do marginal cost. And I've got, let's see, red. I'll do marginal cost in red. So I'll go C prime is equal to 3x squared minus 12x plus 15. And then it says this is the cost for producing radiators, and find your shop currently produces 10 radiators a day. Okay, how was the cost changing at our 10th radiator? So I'll plug in 10 here. Include units on each answer. Okay, so keep in mind, this is rate of change. This is like change in y over change in x. Well, we don't have y's and x's. It's change in c over change in x. What's c stand for? Cost. What's x stand for? The number of radiators. So this is $195 per radiator. At making the 10th radiator, my cost was increasing $195 per radiator right then. Let's look at marginal revenue. That's going to be R prime. And I've got 3x squared minus 6x plus 12. And R prime at 10 radiators is $252 per radiator. Okay. Include units on each answer. I did that. Explain their meaning. I don't need to rewrite that. But that one means, come on. There we go. The cost of production is increasing. How do I know it's increasing? Because that 195 is positive. $195 per radiator. All the time? No. At the 10th radiator. And R prime of 10 means the revenue is increasing $252 per radiator at the 10th radiator. Okay, I kind of think that should make sense. Like, from all that we've done about rates of change and having you look at units for your answer, looking at how this is changing versus how this is changing and what those represent in the problem, I think there's nothing there that's really cause to not understand. Now, this don't know. You may get, you may not. We'll see. So you don't have to copy this down. In fact, just put your pencil down and watch for a minute. I'll start with something really simple that I know every one of you will understand. This is my cost equation. I subbed in 8 and got this. I subbed in 9 and got this. I subbed in 10 and got this. I subbed in 11 and got that. This is my derivative. This is my marginal cost equation. I subbed in 8. I subbed in 9. I subbed in 10. Now, here's what this means. Do you see over here how from the 8th radiator to the 9th radiator, the cost went up $130? And from the 9th radiator to the 10th radiator, the cost went up $172. And from the 10th radiator to the 11th radiator, the cost went up $220. So the cost increased from here to here. The cost increased even more from here to here. The cost increased even more from here to here. So do you think it's safe to say the rate of change of the cost is increasing? The rate of change of the cost, the rate of change is increasing. The rate of change is increasing. Look at these numbers over here. Rate of change, rate of change, rate of change. Rate of change at 8, rate of change at 9, rate of change at 10. Is the rate of change increasing? Yeah, it's going from 111 to 150 to 195. But wait a minute. Wait a minute. Doesn't this mean how the cost was changing at the 8th radiator? How the cost was changing at the 8th radiator? Well, no, it wasn't. It changed that much from the 8th to the 9th. Not that much. But that's what that means. They should match. From the 9th to the 10th. The 9th radiator, it was changing. It was going up by 172. The rate of change at the 9th radiator, you would think would be 172. And at the 10th radiator, the rate of change was 220. It's 195. So see how if I do average rate of change from 10 to 11, average rate of change from 10 to 11, I'm going to do y2 minus y1 over x2 minus x1 is 220. That's the average from 10 to 11. The instantaneous rate of change at 10 is 195. Do you know why they're not the same? Because from x equals 10 to x equals 11, if I were to graph those, they would be too far apart. If I'm going to compare average to instantaneous, I really want those x values to become closer and closer and closer together. You know what would be great? Is up here, if I could, let me pick a color I haven't used, like purple. How about C of 10.1? Let's use 2 points that are closer together instead of all the way out at the next integer, which is 11. C of 10.1. I did the math. You know what I got? I got 569.74. Now, what if I do average rate of change from 10 to 10.1? I do 569.74 minus 550 all over 10.1 minus 10, and you know what I get? 197.4. 197.4. That's the rate of change from 10 to 10.1. Way closer together. Way closer to my instantaneous rate of change at 10. I think that's kind of cool. Like this takes us way back to where I had points P and Q on a graph, and we did an average rate of change and how far apart they were, and I brought them closer and closer and closer and closer together. That's what I just did. I just brought points closer together, and you can see how my average rate of change is getting closer to my instantaneous rate of change, my derivative, the actual instantaneous rate of change. Okay, so what this tells us is if, and of course they're different because of the how far off they were. But what this tells us is, you know how back here it said, where is it? Cost. The cost of producing the next one. So if we know what the rate of change was at 10, $195. If we know what the rate of change was at the 10th one, I wonder what it costs to produce the very next one, $195. That's different from how much it costs to produce all 11. Talking about all 11 versus just the 11th. The cost to produce just the next one. Okay. Fingers crossed. Hope that makes sense.